dose that we use or the number of oocytes that we get and the survival of those oocytes. And this information is very important, especially those that are thinking in protocols of using less drugs or less stimulation. Then we have realized that the low survival happens. I mean, if we take a look globally, the cases in which the oocyte beatification program in any patient is below 67% is around 2%. And in 1.4% of the cases, we have a survival rate of 0, which is very relevant. And this is a very consistent data based in hundreds of thousands of donors beatified, and especially in donors that have very good survival rates. Of course, in the life of the donor beatification, or even in the patients, the more oocytes that we get, the same survival we have. I mean, we don't see any relationship with the drugs, with the doses of drugs, but also with the number of oocytes that we get. And one information that is very important, and especially in countries like yours in India, in which you have a very extreme weather conditions, in which the temperatures outside are very high and the humidity is very high, we have seen that there is relationship in between the temperature, especially the humidity in the laboratory, and the results of the beatification program. And why this is relevant? Well, we have seen that the temperature normally in a good lab with a good air conditioning system is quite stable. We don't see big difference if we split the 4 categories, even that we see a small difference in the survival rate. But if we take a look to the humidity, when the air conditioning system does not work very well, or we have high humidity because the system is not able to dry what is externally very high, in those situations, normally we have seen a relatively drop in the survival rates. So this is important because by first time we're describing that humidity and so how it's affecting the outcome of the beatification program, and we have to take it into consideration. Even that if we take a look to the survival rates and the quarters of humidity, but in a different range of temperature, or just putting all together, we don't see such a difference. But especially in this slide, the survival rate is especially relevant in relation with beatification. Well, it's not the same with the warming. I mean, we don't see any relationship between the warming procedure and the results of beatification. So it's more that at the end, we need to pay attention to the stability in the air condition, in the environment condition in the lab, especially in the beatification, because this is going to condition the outcome of the cycle. And if we just split those numbers and even we do a ratio, with the ratio in between temperature and humidity, because normally both are linked, normally we see, at least here, higher levels of humidity when the temperature is very high, like you have in India, mostly in summer. So we have seen this relationship, especially even when we combine with the ratio. In any lab, the temperature used to be controlled by the air conditioning system, but no one takes care about the humidity. And this is definitely very, very important. So at the end, the summary is that the conditions of the lab especially can impact in the results. And then the more oocytes, the better. Well, this slide I think is very informative because the probability of achieving a baby using beatified oocytes or even fresh increased progressively with the number of oocytes used, with close to, in the oocyte donation program, close to 95% clinical liable rate with a number of oocytes of 40, but just with 20, we're reaching 80% chance to have a baby at home, which is very, very relevant. But what's happening about oocyte beatification and the relationship between beatification and the quality of the embryos that are generated from those oocytes? We have been investigating this for the last years quite a lot, and we have several publications. And years ago, we realized that the embryos generated from beatified oocytes are delayed in between 1 hour or more from the first cleavage and forward. So we see a delay in these events of cleaving. Let's say that the embryo starts to cleave 1 hour later than the embryos that are coming from fresh oocytes, which is the impact of this difference in the implantation potential. Well, if we take a look to this classification, but related with morphology, we start to see especially more difference in the implantation potential, even here is not significant, between those embryos that are coming from fresh and beatified oocytes in those embryos that are compromised with the worst morphological quality. Globally, there are no difference, but if we go directly to some kind of embryos, we see that difference more relevant. But Now with the new technologies, we have done a study. Actually, this study was presented a few months ago in the ASRM in United States. We did a study comparing the score provided by the embryos by using artificial intelligence between embryos that were originated by fresh or by BT5 oocytes. We use in this case the technology of the EmbryoScope with the KIT score version 3 and 2 versions of the AIDA score that are based in deep learning and are making a score of the embryos based on AI. And we use in particular this technology that you may know, which is called AIDA score, which is part of the EmbryoScope, in which we are able to, by a very simple system, which is based in a deep learning classification, we have up to a score from 1 to 9.9, which is very easy to analyze. And even we can take a look to the embryos very easily. So we use the AIDA score, which is very easy for each patient around 1 minute, to compare between the embryos, in this case, the blastocysts that were generated from BT5 and from fresh oocytes. If you take a look to the numbers, in all the type of scores, a KIT score, AIDA score version 2 or 3, and with a very consistent number of embryos, more than 10,000, we see a difference in the score that is normally lower in those embryos generated from BT5 oocytes. So there is clearly an impact of the BTification of the oocytes in the quality of the embryo which is generated before. If we take a look to the euploidy rate, this is data quite much older, we were not able to see any relationship between the euploidy rate and the BTification in the oocyte. I mean, we don't see difference in the euploidy rate of the embryos generated from BT5 and fresh oocytes. This information also is quite relevant. We have seen an effect on the morphology or in the quality of those embryos by artificial intelligence, but not in the euploidy rate. So at the end, which is the effect of the number of oocytes and survival and clinical life rate? This information is also relevant. If we take a look to some of the publications that are actually from years ago, we see clearly a prediction of the predicted probability of having at least one baby in relation with the number of oocytes, and then make a calculation depending on the maternal age, which end up with an oocyte to baby rate of 6.4 globally. And if we take a look to the data from our own clinic, in patients that are less than 35 years old, which include donors, the oocyte to baby rate is 6.5, and in patients with more than 35 is only 2.9. So clearly the effect of the oocyte, the age of the oocyte in the BT5 oocytes, also in the number of and the possibilities to achieve a baby. But this slide is very, very relevant because we're talking about the transition between BT5 oocytes and live birth. And we can see that in standard patients or in oocyte donation with less than 35 years old, again, the live birth by the number of consumer oocytes is 6.5 or 6.6. The number of oocytes to this in percentage, this decreased dramatically, and especially is only 1.8 in patients that are more than 40 years old. Globally is 5.6, but the number of oocytes to achieve a live birth in donors or in patients with less than 35 is around 15. But if we just consider patients for 40 or more years, the number of oocytes that we need to have a baby is close to 55, which is a lot. Globally, we take a look globally to all the standard cycles, we need more oocytes to have a baby than in our oocyte donation program, 3 oocytes more. This is information very important, especially for fertility preservation. Well, what about embryo vitrification? Well, first of all, I would like to mention the very last paper about embryo vitrification that is thinking a little bit, it's starting to describe the rapid vitrification and the rapid warming. The rapid warming is the only one that has been published. We have seen already papers about the rapid vitrification, but not the rapid warming is already published with this paper in APM Online. And in this paper in particular, which was based in blastocysts, what they demonstrate is that if you decrease dramatically, you just need to use the TS solution, the Thawin solution, and then going immediately to the culture media without going through the next steps. And in this case, Lieberman Jorgen was able to demonstrate that the survival rate is similar and the outcome of those embryos is similar, even slightly better. But what about blastocyst morphology inflows in embryo transfer and the relationship with the selection? Well, We have been studying this for many years, especially in the PGTA program. And first of all, the survival rate is not the same if the embryos are coming from day 5 than day 6. Day 6, they survive less. And additionally to that, the embryos, depending on morphology, are affecting also the survival. I mean, the worse the morphology, the lower the survival. And of course, morphology is affecting implantation rate. And is even the implantation rate lower if the embryos are coming from day 6 than day 5. And this difference is becoming more relevant in embryos with worse morphology. Of course, together with that, we can take a look to the embryos that are inside or outside the zona pellucida that are hatching or hatched. And definitely we see lower survival rate in embryos that are totally hatched. And also in embryos that are totally hatched, also the implantation potential is significantly lower in our PGTA program. So you was just wondering, if we just have the morphology, which criteria should be used in order to select one embryo for transfer in between several that we have available? Well, we did a hierarchical classification in which we demonstrate that the first criteria to select the blastocyst, the trophectoderm, should be followed by the day of vitrification. We have to choose always day 5 instead of day 6. Once we have choose in between those with better trophectoderm grade. And finally, the grade of expansion, in which we have to prime to use expanded blastocyst or hatching blastocyst instead of totally, expanded blastocyst and starting hatching blastocyst in comparison with blastocyst. So we tend to have always embryos that are doing hatching or are expanding compared to that are not, like a third grade of selection, in order to being able to achieve a nice grading of the classification of the embryos from 42% of live birth rate to only 6%. But what about artificial intelligence and morphology? Are we able to combine both? Because in many cases, like for example, we have in Valencia, we have the embryoscope, we have the Jerry 2, and we have the morphology. What we have to do in order to select the embryos in between all of them that we have frozen, if we have several? Well, we did a logistic regression in order to understand this, and we end up with very interesting conclusion, which was that in this case, the IDA score, which is based on AI, turning out to be the most predictive variable for pregnancy, followed by embryo quality, the day of vitrification, and the degree of expansion. What this means? That if we have several embryos, we should follow the IDA score or any other score for artificial intelligence for select the embryo for transfer instead of using morphology. So we have to put morphology in a second plane, in a second position, in order to use it to select one embryo for transfer between all of them that we have frozen and we have to work. So what about embryo culture? Well, embryo culture is part of our work in the lab, and we have been trying to optimize culture conditions, trying to use, of course, the best incubators, the best culture media, and the best lab environment. We have been talking before about, for example, the humidity in the lab or the temperature. So in between the things that are relevant in the incubators are the temperature, the CO2, of course, the oxygen, the light that we are avoiding that we don't know if it's relevant, but it's important to have a recovery rate and of course, if we have available the time-lapse technology. So most of the labs has dry culture, especially for the benchtop incubators, and it's a great way of culture the embryos because we avoid contamination and the recovery is very fast. But on the contrary, we may potentially have some kind of evaporation. And the evaporation depends on many things. Depends on the type of lead, depends on the amount of oil that is used in overlay, the type of oil that we use, and also the size of the media droplet that we are using for culturing of our embryos. And that all these things can affect the culture conditions. So we did a study with Gary that was able to analyze in the same incubator 2 different culture conditions. Just putting water and having a relatively humidity of over 60% with chambers of water inside of the incubator, or just using a dried conditions without this water. And we use this dish that has 80 microliters of media, 4 ml of oil, and we can culture up to 16 embryos in each dish. Well, we analyzed some morphology. The information was quite interesting because globally we saw an effect, but we realized that in patients with good prognosis, like oocyte donation patients, even if we culture under humid conditions, we don't see any improvement in the outcome. This is just pregnancy rate. But we observe an increase of close to 12% higher in the pregnancy rate when we culture our embryos under humid conditions compared to dry conditions, and this was significant. The message was that not all the embryos can benefit with these improved culture conditions, only those that has maybe more embryos with compromised morphology that needs like an extra help in order to reach blastocyst. Well, let's move a little bit about the grading of the embryos, and I'm going to show you two types of ways of grading the embryos. One is using automatic platforms for embryo grading by using single images. In this case, we have been working in the last years with the LightWhisper software. LightWhisper software is able to analyze single images that we take in our microscope with just a digital camera. We don't need anything else. We just need to create in the platform of LightWhisper, which is online. We need to create the patient that we are analyzing. And once we create the patient, we have our pictures saved in the folder of the computer that we have been taking by using, again, a camera, digital camera. So we put all these embryos in the system, and in few seconds, we have a score of each one of the embryos, which is related with the quality. We have a score that is from 1 to 9.9. Now, in this case, this embryo has 3.6, and we will put all the embryos there, and in few seconds, we will have a score that is defining the quality of that embryo using an artificial intelligence algorithm. Well, the system is able to analyze the viability, which is again a score from 1 to 10. You see that you have embryos with better score than others that have less. And together with this, we can also analyze the genetics of those embryos. That will be explained later. If we take a look to the capacity of the LightWhisper to predict implantation, well, first of all, if we use the logistic regression, the important thing is that morphology can be combined with this AI score in order to make a selection. The odds ratio of each unit of the AI score is 1.11. This is a comparison between two categories of morphology, A versus C or B versus C with this odds ratio, but this is categorical. And of course, also the day of vitrification and the oocyte origin. So this technology works for embryo selection using single images, but also we have automatic platforms for embryo grading that are based in time-lapse systems. In between those that we have been using more, this is the IDA score that I have shown you before, that is using an automatic score of the embryos from 1 to 9.9, using videos of the embryoscope, and is based in a multicentric database and deep learning. Well, let me show you the relationship between IDA score and clinical results. And what we have tried to do is make a clinical quantification. We did this study in order to provide to the patients some kind of reference when we tell them, okay, your embryo has a score of 6.8. Well, 6.8, if you're in standard cycles, you may expect an implantation potential of 54.4, and if it's an oocyte donation, 59.4. And also we see, this is between the standard and oocyte donation, and also in fresh and frozen embryo transfer. So we see difference with the same scores. We see better outcome in patients that are coming from oocyte donation than the standard cycles, and also we see different score or different outcome if the embryos are being transferred in fresh or in frozen cycle. There are differences in the outcome. So this information again is also relevant and important in order to understand that this score can be related with the outcome, that we can provide this information to the patient and can be relevant in order to understand the potential of each one of the embryos using one score. We just published this paper a few months ago in Advanced Science, which is a very good journal. And I mean, the relevance of this paper basically is that we demonstrate mathematically that if we know the quality of all the embryos that are part of the cohort of our patient, we will be able to predict better what will be the outcome. In other words, an embryo with good quality, just by morphology or by any score based on artificial intelligence, we have better implantation potential if it's coming from a cohort of embryos from the patient that has better quality. Or in other words, the quality of the full cohort of embryos generated from one patient is conditioning the outcome of the embryo that we are transferring. So it's not the same one embryo that is coming from a patient that has only one embryo available with very good quality, that the same type of embryo with very good morphology or very good AI score that is coming from a cohort in which the patient has 6 or 7 embryos or blastocysts with good quality. What about the comparison between the embryologist and the AI score, in this case, IDA score? Well, the level of agreement is between 70 and 63%. It's higher in the KIT score because KIT score is using basically the morphology of blastocysts like we do, and the ADA score is using deep learning, another type of evaluation. So the agreement in between the automatic score and the embryology is between 60 and 70%, more or less. And when there is a match, I mean, with the embryo selected for transfer by the embryologist and the embryo selected for transfer by the AI is the same, the outcome is significantly higher than when there is a mismatch. I mean, the embryo has been selected by the embryologist and not by the AI score. When the embryologist has put in front of the score its own criteria, the outcome of those cycles has been lower. But what about the possibility of using AI to make a prediction of euploidy? Well, it has been done by several attempts. One of the platforms that has been used for this achievement has been EMA. EMA is a platform developed by a company called IVF in Israel, and it's connected with the embryoscope and with the Jerry. And we have been using this system in our clinic to evaluate the quality of the embryos with a score that you see from 0 to 100 using videos of the embryoscope. So this platform can be connected to any time-lapse system and is able to provide a score like the AIDA score using with the embryoscope, but this can be connected to any type of time-lapse system. For example, in our case, we have been using the EMA in the Jerry incubators. Well, in between the algorithm that was developed by AABF, they developed an algorithm which is using these 5 categories or these 5 features of the embryos: morphokinetics, the morphology of the blastocyst, the cell division activity, which is measured with the borders of the cells, the number of mitochondria, which is an approximation, and also detecting automatically the pumping events. These 5 features are combined independently, and they have developed a model for prediction of euploidy with a precision of 90%. These are the results of the validation of the study and the test with those number of embryos used. And in any case, we were close to have a 90% precision, which means that in 90% of the cases, the software was able to identify an embryo that was chromosomically abnormal with somehow some kind of accuracy. Well, there are also automatic scores available in the market that can be used for detection of aneuploidies or to decrease the chance of transferring an aneuploid embryo. Most of them are in the embryoscope, but also in other systems like you have seen, like Whisper, the ERA, EMA, Chloe, etc. These are the relationship between the results of our PGTA program and the AIDA score. The higher the score from the AIDA score, the higher the euploidy rate, as you see here, from 31 to 63%. We see clearly this relationship. And also, we use another score, which is the Live Whisper, that is using single images instead of videos. And with the Live Whisper software, we saw that this AI score was significantly higher in embryos that are euploid compared to those that not. These are the distribution with the box plot. And you see with data classification of the AI score in intervals, we observe that the higher the score, the higher the chance to get an euploid embryo. Finally, what about embryo quality and stimulation protocol? I have put this part of the presentation especially for you, for doctors, because you are the responsible to give us the product that we are going to manipulate in the lab in order to provide you as much embryos as possible. And you must take into consideration that your decisions in the stimulation protocols may condition the quality of the embryos that we generate. For example, and this is a very nice paper done by one of my colleagues in Valencia, Elena Labarta, the higher the ovarian response after stimulation for any kind of IVF cycle, the higher the number of euploid embryos that we achieve, but not the higher the chance to obtain an aneuploid embryo. I mean, the aneuploid rate is stable independently of the dose of gonadotrophins or the higher doses, and the euploid rate is stable. Of course, the more oocytes that we get, the more chance to have euploid embryos, and this is obvious. But what about this is a very nice comparison that we presented a few years ago in SRM. What about the same patient if we compare one stimulated cycle and one unstimulated cycle, and we take a look to the quality of the embryos that we generated? First of all, we did PGTA. So the euploidy rate per metaphase 2 was comparable between stimulated and not stimulated cycles. And also the euploidy rate per biopsied embryo is similar between natural cycles and stimulated cycles. So at the end here, we demonstrate that just using stimulation to obtain more follicles and more oocytes does not affect the chance of that embryo to be chromosomically normal. But what about ovarian stimulation? This is in our oocyte donation patients, and we just make a comparison between a cycle with donors using only recombinant FSH or doing the combo with HMG in order to decrease the dose or to decrease also the cost of the cycle. Well, most of the cycles that we do in our oocyte donation are only with recombinant FSH, and if we take a look to the number of oocytes retrieved is significantly higher with this use of only recombinant FSH. And if we take a look to the embryo generated from our oocyte donation in the same cohort, using AI tools like KidScore, especially IDA-score version 1 and 2, you observe that there was no difference in the quality of the embryos obtained from stimulation only with recombinant FSH in comparison with this comparison with HMG. But what about the quality of the embryos? And if we're able to link this with stimulation protocols. So I bring you here one paper that we just published this year in Human Reproduction, in which basically we demonstrate the utility of one score, which is from 1 to 5 provided by the Jerry. It's called Extend. And we just make a study to make a relationship between the implantation potential and these extend categories. And also we observe this relationship between the live birth rate and these extend categories from 48% to only 13%. So a nice relationship between this automatic score and the outcome. So because this score is automatic and can bring you more objective evaluation of the embryos, we take a look to the classification of the embryos in different stimulation protocols using only recombinant FSH, combining with HMG or combining with LH, for example, with pergoveris or using only HMG. And we take a look to the proportion of top quality blastocysts that are those with one category was significantly higher in the group that we use recombinant recombinant LH, the pergoveris. And also when we take a look to the proportion of top quality blastocysts, we're able to obtain like the double proportion of top quality blastocysts when we use the combination of recombinant FSH and LH in comparison with only recombinant FSH. If we take a look to the embryos in another way, this was using morphokinetics and in particular a system which was cloud-based. We upload hundreds of thousands of embryos to a cloud with several features, and we distinguish between those that get an implanted and ongoing implantation or those that did not implant. And then this proportion of top quality embryos using this system was compared between stimulations using only HMG and stimulation using the combination of recombinant FSH and LH, like in the pergoveris. And we observe again an increase, or we just double the proportion of top quality embryos when we use this combination of drugs. So trying to conclude, because we have seen many things today, of course, the age and the number of oocytes are the most powerful factors for success. The probability of achieving a child is not the same in the oocytes from young women than old ones, but the more oocytes, the better. And also, if the patient is older, the number of oocytes needed is significantly higher. And when the patients are in between 35 years old and they get between 10 and 15 oocytes, that should give us a chance to have around 70%. But the same number of oocytes in a patient over 35 years old will decrease this chance of around only 25%. So the age is very relevant to make any kind of conclusion. If we think about the embryos, the blastocysts, we know that the blastocyst BT5 on day 5 with the best trophotic degree are the most priority, or those that we need to prioritize in order to do the warming. The ability to predict embryo survival of clinical outcome is important in order to elaborate the cryopreservation programs. And also we should pay attention trying to understand the blastocyst features and how they are affecting the clinical impact, especially in cryopreservation. In the particular case of the AI scores and the IDA score, we have seen that a nice and higher correlation between the clinical pregnancy rate and the variables provided by the embryoscope, but also with the morphology. And we just end up knowing that this tool is very useful for selection, especially in BT5 blastocysts. But also it's important to pay attention that the embryos that are coming from BT5 oocytes have significantly lower scores using AI than those that are coming from fresh. So at the end, is a good way to assess the embryo quality of the embryos, the embryo quality of the blastocyst, and also a good way to be prepared to any future impact of any type of protocol that we're using if we're just able to take a look to the blastocysts that we generate. In regarding to culture conditions, I think definitely is also in which we have to pay special attention. And in particular, we think about the humidity in saturation. This is very important for the culture conditions, but it's related also with the volume of media, with the amount of oil and the type of oil. And also we're using sequential or single step, because if we change the media in day 3, probably this effect of the humidity is not really relevant. In the case of the IDA score, we have seen a nice relationship between the IDA score and morphology. The probability of having a baby is related with the OPD rate. And in the case of embryos that are coming from the frozen embryo transfer program, the higher the score, the better the outcome. Normally, we have also better scores, of course, in oocyte donation than in standard cycles by far. And there is an important coincidence between the embryologist and the score provided by the IDA score. But when there is a mismatch between both, normally, if we follow the score done by AI, we probably will provide more chance to have a baby to our patient. And if we think about the non-invasive PGTA and the model that we have applied to predict morphology, to predict LPD, definitely these tools may help us to reduce the need of invasive biopsies in some of the patients. Also, these technologies are decreasing the chance of transferring an euploid embryo. And even that there are automatic algorithm that has been diagnosed to do the selection of PGTA, still, I mean, we need some time in order to have this type of tools commercially available, even that in some cases we have it. Finally, we think about the stimulation protocols and embryo quality. Of course, the goal of embryologists is to optimize the ratio between embryo quality, between embryos generated and the number of oocytes that we have. The oocyte quantity and quality decrease with the patient's age, for sure. The more oocytes and embryos, more chance to have a baby. We have seen that recombinant FSH provides a higher number of oocytes, but this is not affecting the quality of the embryos. But in any case, even though oocytes or embryos should be analyzed very objectively, not subjectively, we have seen that overstimulation like itself does not affect the embryo development or quality or the OPD rate, but the combination of recombinant FSH and LH, like in the pergoveries, seems to produce a higher proportion of high-quality embryos than the urinaries. Finally, let me introduce you some of the embryologists that are participating in my team of research. Those are senior embryologists working in Valencia. If you want to follow me by Instagram, this is my link, of course, by LinkedIn, and all the studies that we've done are financed by European Community, and also Spanish and local government. This is the team of PhD students that are working with me, actually. They are based in Valencia, and again, are funded by European Community and also local funding from our region. And this is just a picture of my city in Valencia, and also the team of embryologists that are helping me in this research. This is from exactly 1 year ago in Valencia in winter. And that's all from my side. Let me stop sharing the screen. Give me 1 second. And I guess that now the paper is open for any question, discussion that you would like to go through.
Yeah, so before that, Marcus, I would like to take the privilege to thank you for such a wonderful session. And I hope this will definitely be of great help to both the clinicians as well as the embryologists to understand their roles, their role duties, and to know what clinicians' perspective is for their embryology and what they expect out of from the embryologist. So although I think you have covered most of the topics, right from oocyte cryopreservation to incorporation of AI tools, and then embryo vitrification, then embryo culture, then non-invasive screening using AI tools. So so this was quite extensive, I think, presentation, and although you have covered all the topics, so still, if there are any questions, and I will now open the forum for the embryologists and my clinicians, Pan India. If you have any questions, you can either write it in the chat box or you can raise your hand. So if there are any questions, so you are most welcome. So today we have Marcus with us to answer all your queries. So meanwhile, Marcus, there was a question. There were some students were also here, and we were discussing. So we would want your comments on efficacy of using the non-expanded embryos, like those who are 2AB or 2BB quality embryos. Although we have been getting good results using 3 or 4 BB embryos, but what is your comment on 2 BB embryos, which are non-expanding?
Well, non-expanded, because we normally, you know, that in Spain use another type of nomenclature for that. But I mean, we prefer always, I mean, it depends on the type of patient, but especially if it's good prognosis patient, we prefer to leave 1 day extra instead of BT5. So we prefer to leave to day 6 instead of BT5 early embryos on day 5. That's my opinion. Of course, again, the criteria for vitrification may depend on the type of patient. We are super strict when we vitrify embryos for site donation program because the patients are paying for a cycle with high chance to have a baby, and in that case, we don't have any chance. We don't want to have them any chance to transfer embryo with low outcome. But in the case of a standard patient, we may decide if we have a lot of embryos or very few, we may even vitrify an embryo that is not fully expanded. But it's an option that we will leave. First of all, we'll leave until day 6. And if it still is not expanded, depending on the number of embryos that we have available for the patient, we can take a decision.
Right. And would you recommend giving a laser so that just to facilitate the hatching? Because the basic challenge is not the quality of the embryo, but the hatching. Probably there are less probability factors that this would hatch out. So
yes, I mean, this criteria is very subjective too. Assisted hatching, I know that there are clinics around the world that are doing assisted hatching to all the patients, and some of the cases in which the it's only from some of them to some of the embryos. In our case, we do assisted hatching only to some of the embryos that we have, and we do it exactly in those cases, which are those in which the quality of the embryo is relatively compromised, and we need to help them a little bit. So in those cases, we just do assisted hatching. We help the embryos to exit from the zona. So, you know, our intention, even that is subjective, is to do assisted hatching only to some of the embryos that we have.
Right. So meanwhile, I think there are some questions.
Right. Yeah. So on the same lines, I think we had one question in the chat box as we were discussing about laser. Sorry. The question is, does the laser-assisted hatching increases the incidence of MCMA twins?
Assisted hatching increase the chance of what? Of?
Twins. MCMA twins. Monoamniotic twins.
I mean, if you ask me about my experience or if we have like any kind of analysis of our data, we haven't done. I remember that we have been checking the couple of years. Last year, we did a couple of abstracts about assisted hatching only in collapsed embryos that were coming from embryos that were collapsed in fresh, that we see this, how to say, it was not a forced collapse, it was a natural collapse during embryo development, and we checked between embryos that we did assisted hatching and not. And just to show you that we did not observe an increase in the twins by doing assisted hatching. So I don't have such a kind of experience. We don't see this increase in the risk of having twins because of assisted hatching, but maybe you can have. And of course, this is clearly also depending on the type of or the way that you assisted hatching, that this may condition the production of more twins.
I hope that's been answered. And so next is a very crisp question. Just 4 AB on day 6 or 2 AB on day 5? Which one will you prefer?
Well, I don't think that from a perspective of the trophoctoderm, an embryo that is 2 can be classified like A by trophoctoderm, to be honest. So it's, I mean, for me, it's difficult to consider that. But in our algorithm, the priority is the trophoctoderm. Secondly, is the day of vitrification, and the third is the grade of expansion. So I will choose always the embryo with the best trophoctoderm, and then day 5 first.
Okay, so refractoderm is the priority.
Right.
So if we have 8 refractoderm, that goes earlier, and then the vitrification day 5 or day 6, and then the expansion grade, right?
Exactly.
Okay, that's great. That's crisp answer to the question.
And nothing about inner cell mass. Nothing about inner cell mass. I mean, inner cell mass is quite much less relevant. One is present. We don't care if it's better or worse, to be honest.
And there was one more question. Non-invasive PGTA versus invasive PGTA. And maybe if we can add on to it, the AI tool-based PGTA. So out of these three, so how would you rate on the basis of priority?
I mean, up to now, we cannot substitute the PGTA, the standard PGTA, the invasive one, with the non-invasive. There's no way, because the level of accuracy that has been achieved by the non-invasive PGTA is still not enough, because we need to have a 100% accuracy. So if there is a clear indication of PGTA, we should go through the invasive. If there is not a clear indication, or we want to use an alternative way of ranking the embryos to select the first one for transfer in between several, the non-invasive PGTA, using AI or not, is very promising, and I will always strongly recommend it. And in other words, if there is a clear indication, for example, we only do here in Spain PGTA to patients above 38 years old with repeated implantation failure or 2 miscarriages. In that case, we indicate the PGTA. If it's not that case and the patient is still interested in reduce the chance of transferring an operate embryo, I think this type of tools are very, very interesting. What I don't know, and we are working on it, but I have to admit that this is being more complicated than expected, is the intention to combine the non-invasive PGTA by using the analysis of the DNA, free DNA in the media, with the tools of artificial intelligence. If we're able to combine both and increase the accuracy. Up to now, we had not been able to do it.
Because we used to actually combine, maybe previously we have also spoken about combination of time lapse and PGTA, and here comes a new combination of maybe non-invasive screening along with the AI tool, which possibly helps.
Yeah. That may increase a little bit the accuracy, and maybe in the near future, maybe we're close to substitute the invasive PGTA by the combination of these two. But still is not possible. And again, if you take a look to the results of non-invasive PGTA, and I know that you have been working on that and you are very interested, it's interesting to see that you have to change or manipulate the standard protocol of embryo culture to increase the chance to find DNA in the media. And this is a little bit against embryologist point of view, because the DNA is in the media when one cell has been degenerated. The embryo does not release DNA in the media if it's super healthy. So we are extending the culture one day more to increase the chance to have one cell of the embryo degenerated that will release the DNA in the media, and then we will be able to analyze. If you don't change your culture conditions, in our experience, only 20-25% of the media that we analyze has more DNA than the amount of DNA from one cell. Okay, so it's very strange to find DNA in the media if the embryos are cultured under standard conditions. We need to make something different in order to obtain that DNA.
That really makes sense. And just an extension of this thing, this question only, many times it happens that in non-invasive PGTA, we get to report no DNA detected or insufficient DNA. And probably there are chances that the couple got their embryos frozen. So what do you recommend in those cases? Should a repeat NIPGT be done, or should we be switched to the invasive technique if we want to do it on frozen embryos? Yeah.
If there is an indication, I will of course go to the invasive. If the embryos are frozen, I mean, we know that the frozen embryos, because most of the cells die in the, not most, but some of the cells die in the process, they release the DNA, and we can detect more probably, or there is more probable. Even that all the studies done in non-invasive PGT in frozen embryos leave the embryos in contact with the media for 1 day. So it's like we would just warm the embryo, we keep 1 day on culture, and then we analyze this culture media. Of course, in both cases, with a non-invasive or invasive, you need to freeze the embryo again, which is another manipulation that I don't like it. So if there is a clear indication, I will go to a PGT invasive. If not, I will go directly to a transfer. Another thing that is important is that the more DNA is in the medium which the embryos are growing, the worse should be the quality of that embryo, or the more cells has been degenerated, because a very nice, good-looking embryo will not release cells, will not release DNA in the media, will not have damaged cells that will then release DNA in the media. So I believe what I have seen in our own data is that the less DNA are in the media, the better is the quality of the blastocysts.
Right. That's an interesting observation. I think we also need to look more into our analysis on the same front. Yeah. Right. So we have the question on sperm selection, and the question is, what is the best way for sperm selection in case of severe OATS patient, that is oligosteroteratosis patient?
Well, the tools that we have for sperm selection available now are still, any one of them has been able to demonstrate an improvement in the outcome. And of course, also we have another tools that we can use for ICSI that are the AL tools that are, we use a microscope with a camera connected to a software, and we just focus on the sperm, and then the software help us to select the one that we're going to microinject, which is very interesting, and we will need to know if this is working. Then we have tools for sperm selection like the MAX, the magnetic beads, the Pixie, and maybe also the IMSI, like an alternative for selection of sperm. But the scientific background behind is still controversial, has some kind of controversy. And what I would really like now, I mean, if we think about the method for embryo selection that for me has more future and has also more potential, and also is clean and advantage just by logistics, because we are automating a processing microfluidics, microchips of microfluidics. Definitely, this is the point. We have been using microfluidics. We have seen clearly that improves the sperm quality. It's difficult to demonstrate that this is proven in the sperm quality is at the end reflected in the embryo quality or in the outcome, but it's a very simple technique. It saves you time, probably money and human resources, but because you don't need to use the gradients or swim up or do centrifugation. So for me, if you will ask me which is the best choice for any type of patient, even including severe factor, of course, not ultra severe, because if it's very severe, there's no way to do any kind of selection, is the microfluidics, definitely.
Great. So microfluidics.
Okay, microfluidics. Yeah, that is.
Right. So at the same time, there's also one thing related to this, and that is sperm freezing, because we know for a lot of OATS patients, doctors also prefer TISA. But at the same time, TISA on the same day may not be that very helpful. So sperm freezing methods for surgically retrieved sperm, what's your take on that? What should be the best way?
Ideally, I would love to have always the biopsy now, because we can, of course, because we can vitrify the eggs at the end if we don't find the sperm. Ideally, we have the sperm the same day of the oocyte retrieval. We especially in extreme severe factors in which the sperm production is very limited, we increase the chance to find a sperm viable if we use a fresh sample. But normally this is not possible. I can't talk about my experience here in the clinic in Valencia. It's impossible to coordinate. Only a few cases we do to coordinate the urologist in the day that we have the oocyte retrieval. So it's very difficult to do it. But if you will ask me what do you prefer, I prefer fresh biopsy and going directly to the fresh sperm instead to vitrify, especially if it's coming from the testicle. That is, in many cases, the quality is compromised, and we know that later on many sperm does not survive. So it takes us longer to find a sperm viable for microinjection, and that's important too.
Right. So the preference is oocyte freezing over the sperm.
But still, but if given you a chance that you have to preserve the sperms, surgically retrieved sperms, what is the best method that you would recommend?
For sperm freezing?
Freezing, yeah.
Well, here in Valencia, actually, we have used only one technique, which is we're using these dry ice pills. And we always like it because I mean, what we use is a surface of dry ice in which we make small holes and we just put there the sperm with the cryoprotectant, and we vitrify. We make pills that we just put in the cryo tubes. And we use this technique. I don't know if it's the best one or if there are others that are probably better. I don't know. But this is the one that is able us to, let's say, make more fractions of the sample, which means that we can use only one pill for one ICSI. And if it's failing, we can use another one, of course, depending on the quality of the sample. So it's the best technique in order to have small portions of the sample for several attempts. But I'm sure that maybe it's not the one with the better survival. There are other options that in cryotubes, in strips, there are many other options to do it. But in my case, or at least in our clinic, we have experience only with one of them, and we are quite satisfied for sure in comparison with the straws or cryotubes that may be working better or even could have better results, but we don't have experience.
Okay, yeah. So that way the sperms can be used more judiciously rather than spoiling the whole sample. So
exactly. We have for several attempts.
We have question 10 to 15 oocytes for 25 to 40% in about 35 per embryo for single embryo transfer or double embryo transfer. I think if you have 10 to 15 oocytes, or maybe 25 to 40% or 25 to 40 age, about 35, should you recommend single embryo transfer, double embryo transfer?
Well, we have a very super ultra mega strict with that. We do always single embryo transfer. Always. We have 98% single embryo transfer in our clinic. So we never consider any other option. And I know that this is sometimes impacting the concept in many places all around the world. I mean, in my experience in India, for sure, in South America, that they love to transfer more than one and have twins or things like that. But we are super strict with that. We never consider more than one embryo. Never, ever. It's very unusual. Very, very unusual.
Wait, so it's like single embryo transfer ever. So that actually is a crisp answer.
Yeah. Is that we do not consider that the number of embryo transfer is an indication. The indication is always one.
Okay, great. We have another question.
So what is the most optimal volume of media droplet to culture embryos? So what is the minimum volume that must be?
Maybe for both single culture or double or group culture.
That's a very good question. And I will say that it depends on the system that you have for culture. If you culture under human conditions, I will say that the volume is irrelevant in between a volume that is, of course, a volume that is able to manage easily. We never make drops of less than 20 microliters because we'll be very small. And normally our drops are 50, and sometimes you see drops of 100. So if you use humid conditions, your incubator has humidity, or you change the media on day 3, I will say that this the volume is not relevant. If you use single stem media and you don't change on day 3, I will say that the more volume, the better. Even that the more volume of oil, the better. Normally, we use 50 microliters of oil of media, and 10 milliliters of oil in the standard dish, and that's plenty enough for us on the dry conditions. That's our experience in standard culture. If we go to time lapse, it's tricky because depending on the time lapse system, there are some of them with more or less oil, or more or less amount of media. And we have realized that the worst results for us when we use single stem media without changing is in the incubator, and we have less volume of media and less volume of oil.
50 microliter of media, you're talking about basically if it's a group culture, and how many oocytes or embryos per group, or it is 50 microliter for one?
We do not do group culture. The only place that we do group culture is in the Jerry and in the Embryoscope Plus. In the Embryoscope Plus, they have 8 embryos, and they are cultured in 160 microliters. And in the Jerry, you have up to 16 embryos, and they are cultured in 80 microliters of media. So you have these two examples, but if you ask me which is the minimum volume for your culture, again, it's the same. It depends if you are using a single step or not, or if you change the media on day 3 or not.
everyone.
Right, so the question again is moving around PGTA. So the chances of mosaicism in PGTA leading to false positive or false negative as compared to NICS.
Well, about mosaicism, I think for me the situation is solved. It depends. I mean, for me, the mosaic report is a problem that the genetic lab is giving to you. The genetic lab giving to you the problem, like we say in Spanish, the brown, and then you will see what you do. And this should be wrong. I mean, actually, for example, with the platform that we're using from Juno Genomics, which is the company by which we work, which is combining NGS with SNPs, they provide us the embryo if it's euploid or aneuploid. What they do, if it's this mosaic with high rate mosaic, they put us like aneuploid, and if it's low rate mosaic, the report is telling us that it's an euploid embryo. So we don't have reports of mosaic embryos, almost never, very few cases. So we don't have this problem like we used to have before, because we know that the embryos, mosaic embryos with low profile or a low proportion, they implant as good or as well as the euploid embryos. So at the end in the lab, we don't care. What we want to know is if we are transferring that embryo has the highest chance to implant, and the lab should provide us a cutoff value to know if the embryo is euploid or aneuploid. We don't care if it's high risk or low risk mosaic, because at the end, what we want is to transfer to a patient an embryo that is eager to implant. So for us, the problem of mosaicism disappeared, since the platform that we're using now, they do not provide us this information.
Okay. Dr. Kanika, yes. So there's one question from Clinician, and it's like, does the number of days of gonadotropin injection have any effect on euploidy status of embryo? Your insights?
As far as I know, there is no impact. But I mean, you mean the longer the protocol is, more days using gonadotropins, how is affected? Well, as far as I know, with our data, but again, this is not very, still is not very consistent because of retrospective data. I don't see that effect. Maybe there is something there that we haven't been able to analyze or to realize, but I don't have any relevant information to provide to you about this.
Okay. Fine.
So the next question is regarding the embryology part. Again, coming back to the surgically retrieved sperms. So which is the best parameter? What are the best parameters to identify the usable sperms obtained out of a TISA or TZ sample? So will pentoxifylline, do you recommend using pentoxifylline for all these such cases?
We use pentoxifylline only when it's necessary, to be honest. If we're able to identify motile sperm, we don't use pentoxifylline, and if we are not able to identify, we use it. So we use it when it's necessary. That's all. Of course, if we need to use it, we may expect that the quality of that sperm sample is worse because we need to activate motility artificially with pentoxifylline. But we use only when it's necessary.
Okay, so earlier it was said that the pentoxifylline use is not good for these IVXC cases. So it's not
to be honest, I don't have, at least in our hands, we don't have this relationship between the use of pentoxifylline and the negative impact on the outcome. To be honest, I don't see that effect.
Okay, so that can be used, at least not very extensively, but judiciously.
When it's necessary.
Wherever necessary. Yeah.
I think the last question on the chat is, how much is PGTA reliable? As there are not many studies to validate it, it's also in red signal. And if we are taking biopsy from trophectoderm, then how would an ICM aneuploidy be reported? So how much do you rely on PGTA?
How much I rely on PGTA? I rely 100%. I mean, actually, the papers that are published are clearly demonstrating that the negative predictive value is 100%. I mean, when you transfer an aneuploid embryo from PGTA, I mean, you take a look to the papers that were published in New Jersey by Richard Scott and his group. they were able to demonstrate that an embryo that is reported like an euploid by PGTA, by NGS, the probabilities of implant are 0. So I think it's actually the only tool that we have available that has this negative predictive value. Of course, the positive predictive value is not 100% because we transfer an euploid embryo and in some cases do not implant. But actually, I think it's the best diagnostic tool that we have available. But it's true that it's not for all the patients. Should be applied only those patients in which we have a clear indication, which means that we have a high risk to transfer an euploid embryo. And in those cases, we need to do PGTA for sure.
Actually, I think till date, even till today, PGTA that remains to be a gold standard when it comes to aneuploidy screening.
Of course.
Yeah, and most of the labs, these genetic labs, they often use I don't exactly remember the paper, but there was some paper published with some pictures that if the whole embryo is euploid and you are taking out some few abnormal cells and you report the whole embryo as abnormal. There is some paper.
That's true, but it looks that the frequency of those cases is very small. Of course, there is a chance that you are analyzing the trophectoderm, which is euploid, and the initial mass is aneuploid. On the contrary, it could be also that you are analyzing your trophectoderm, which is aneuploid, and the initial mass, but this is very infrequent. I mean, and it's more related with, let's say, mosaic embryos or embryos in which the chromosomal abnormality has been generated during the embryo cleavage and not during meiosis, which is the most frequent cause of chromosomal abnormalities, the defects in the meiosis like itself, not in the mitosis after fertilization.
Right. So I think that ends with the questions, and probably it's really very hard to say goodbye for such a wonderful session. But I would request Naval to give departing this.
Yeah. So. Thank you very much. I think this was the first such attempt from Indira Fertility Academy, which is an academic wing of Indira IVF, to promote academics in the embryology field all over pan-India. So most of our webinars initially were used to be only for the Indira IVF team, but this time onwards, we opened it out for everyone. So thanks to IFA, at the same time, thanks to Dr. Meseguer, because he allowed us, he gave his permission so that we can share the platform for everyone pan-India. And thanks for the insights. We had a lot of questions, and that itself shows that, yes, it was an impactful presentation and people did love it. And we had more than 200 people attending this webinar. So that also shows the interest of the clinicians and embryology around. So thank you very much for your time. I knew you have been traveling and had some busy days, but still you made yourself available. And apologize for the small mistakes at the time of introduction. I hope I corrected the CV at the end, which I hadn't put across. And thank you all the doctors and embryologists for attending the sessions in the good numbers, and also being participants who are asking questions and being involved in the presentation. So thank you all of you, and we'll continue this IFA webinar session with different topics coming up further with other different QLs also.
Just for the information for everybody that our special webinar sessions with the international faculty, this happens on third Friday of every month. So it would please ensure that you are there as a part. We would want to see you. We would love to have you on and we would love to have your questions as well. So see you next third Friday of January, right?
Thank you, everyone.
Thank you very much.
Thank you.
Bye.